Okay, and we're go. So we're going to do the weather today, so in my usual animated stuff, just gonna keep it low key. I was this close to canceling all my classes today. But I was like, no, the students need me. I know you'll all be upset that you couldn't have the quiz, so I sorted on that. No, I'm kidding. It's like it's a different ballgame. You know, when your student in class gets canceled, you go, yes. When your teacher in class gets canceled, it's just stress because now like, when am I going to make up that class? How am I going to make up that class? Am I going to have to do a class on reading day now? They're all going to hate me. So yeah, you literally risk death not to miss a class. Because if you die, you won't have to make a class. So. But as long as I survive, I know it's going to be something I'll have to deal with later. So I'm like, let's just go. Let's get this bread. I got my halls, I got my tea with honey and lemon. Let's do this. Hope that quiz wasn't so bad. I'm curious as to, there's a problem on this quiz. This is version A. It's not the hardest problem on the quiz. I just wanted to know, when you saw it, what did you think?
So x to the third minus 3y over x.
Yes.
And then it's linear order differential.
B substitution.
No. That's it.
Let's do
Linear differential.
Huh? It's a linear first order ODE. It's an integrator.
Load.
Let's write it as dy dx equals x cubed minus 3y over x. And you can move this on the other side if you want. dy dx plus 0xy equals x cubed. Standard form for so linear is probably the only way. The v substitution wouldn't work because if you did the kx and ky thing, you wouldn't actually get the original function back. It's not separable. So yeah, it was actually
it's not the same powers.
Could you
yeah, but it's not the same power.
do the next one?
Just no. You'll see the answers. What you should do is try the other. Look over your quiz when you get it back. Try the other version to make sure it's actually in your mind. But just thought I'd ask that, just to see what you guys thought. So that was linear. The other one was separable. And then there was one where the v equals y for x substitution would work. So it is a good time. So I'm glad I didn't miss it. So we are just going to, again, take it easy. We're just going to finish the handout here. Get through a couple of these examples.
We're just going to finish the handout today?
I don't think I'll have time to do much more than get through this, so let's just get through it. The next thing we're going to cover is exact equations, which I asked on the bonus. So yeah, last time. We derived.
That's how hilarious.
By the way, this was the answer to one of the problems on the quiz. So that's the general formula for the mixture problem. Q what?
Q of t. It doesn't matter.
No, this is Q of t. What we call the initial condition is Q of 0 equals Q. So that is a separate equation. Okay. So we derive that, so hopefully we understand what that means. So Q is just the amount of pollutant in some solution. We want to actually talk about Q without having to talk about the rate of change of Q, but that's just concentration in the rate of flow in with this formula. It will always be a first order. Worst case scenario is going to be a first order linear. If this guy is non-zero, if this guy ends up being 0, it ends up being separable. So in either case, it's not going to be that bad. The hardest thing for problems like these is being able to read the word problem and pick out the right numbers. So I believe we did problem 2 and 3 already. And we did not do problem 4, or did we?
Could we do number 1?
We did 4 or 5.
Huh?
We did not do 4 or 5.
We did not do 4 or 5, so let's knock out 4 and 5 quickly. Nothing else to talk about here, so let's just jump into it. Tank with a capacity of 100 gallons initially contains 50 gallons of water with 10 pounds of salt in solution. Fresh water enters at a rate of 2 gallons per minute. The well-stirred mixture is pumped out at the same rate. Compute the amount of salt in the tank 10 minutes after the process begins. So let's actually find our variables. C in, R in, R out, V naught, and Q naught. What's C in? Zero. Because fresh water is coming in, there's zero concentration of the pollutant. What's R in?
2.
Right, water enters at 2 gallons per minute. R out, also 2, it says it leaves at the same rate. What's the initial volume? 50. And Q naught?
10 pounds.
10. Okay. So once you actually do that, the rest of it is a matter of plug and chug. So we are going to see here. So Q here is representing the amount of salt in the tank. So Q prime is going to be equal to, well, 0 minus Q over 50 plus 2 minus 2T. So that's not changing. This is Q. So this becomes Q prime equals minus Q over 25. So that's separable. So this would mean dQ Q equals minus 1 over 25 dt. And we can integrate both sides. This, the right side, that's the value of Q. The left side, minus T over 25 plus a constant. And if I E both sides, I get that Q is equal to some constant. Now we know that Q naught is 10, so Q of 0 equals 10. This means if I plug in 0 for T, Q will have a value of 10. That means your C equals 10, and so that's the amount of salt in the tank at any time T measured in minutes. Yes, measured in minutes. And the question simply said, how much salt was in the tank 10 minutes after the process begins? So this just means they actually want Q of 10. So, 5. That's your answer. Pounds. I don't particularly care about the units. In physics, you have to really be careful of the units, but in math class, I don't particularly care. As long as the units match up as you're working through the problems, I don't really care. So that's whatever number it is. We don't have calculators, so that's fine to leave your answer as that. So notice that will be a little less than 10, because e to the minus 2/5 is going to be a little less than 1. So hopefully no questions there. Nothing new to talk about there. Unless there are questions, just stop me if there are questions. Otherwise, I'm just going to power through. We are going to move on to 5. A 200-gallon tank is half full of pure water. A salt solution with a concentration of 5 pounds per gallon is flowing into the tank at a rate of 4 gallons per minute, while the well-stirred, well-mixed solution is flowing out at a rate of 2 gallons per minute. A, find Q, the amount of salt in pounds in the tank at time T, and find the concentration of salt in the tank when the tank overflows. Now, again, let's find our variables. C in, R out. Q naught, V naught. Okay, C in.
5 pounds per gallon.
5 pounds per gallon. Remember I mentioned the units, so that's, I'll tell you 5 right there. Rate in. 4, rate out. Initial amount of salt.
One.
Huh?
Zero.
Zero. So it starts out full of pure water, so there's no salt in the beginning. Initial volume,
100 gallons.
100. But the 200 gallon tank, that's half full. So that means there's 100 gallons. So,
I have a quick question. When you're dealing with the V now, the volume is it's just like the whole volume of the tank,
V naught is the initial volume. only.
like with the mixture and everything mixed together, right?
So this is initial volume. If you want the actual volume, like V of T, that's going to be V naught plus R in minus R out times T. That's the guy that was in the denominator. Right, so this is the volume. V naught is just what it is in the beginning. Yeah, so we go in and we plug this guy in. Q is the amount of salt. Here we have a non-zero number here. So that's going to be 20 C in times R in minus Q
Times 2.
over, it's going to be times 2, but it's going to be over
P naught plus.
plus 2T, right? Because it's 4 minus 2T here. Now notice that their volume, therefore, will be increasing. It increases by 2 gallons every minute. And so that tells you eventually it's going to overflow. And they ask you about what's going on at the moment of overflow. So we know that the volume is growing here. So this means that we have Q prime equals 20 minus Q over 50 plus T. How do we solve that? Huh?
It's a linear first order
It's a linear first order.
integration factor.
So what's your P?
2 over
1 over 50 plus T.
1 over 50. Remember, you have to put it in standard form to know what the P is. So Q prime. So that's our P right here. We're going to find the integrating factor. Mu is e to the integral of the P. It's going to be e to the integral of 1 over 50 plus T. That's e to what?
ln
ln 50 plus T, which is
50 plus T.
50 plus T. And so we're going to multiply through by 50 plus T. Now, upon doing that, what does the left side become?
100G plus 10T squared plus. Oh, right, left side, sorry.
The left side.
After you take the integral?
No, after I multiply through by this.
Q times 50 plus T.
Right, you just did Q times 50 plus T.
Differentiate.
Derivative, right? Becomes the product rule. And then over here we have there's 20 times 50 plus T. So now we can integrate both sides. This is Q times 50 plus T. Here we're going to have, well, 1,000 T plus
T squared.
10 squared
Plus 2.
plus C. And then we are going to, so the plus C is important here, plus C is not important here. You could put it here, but it would just make this look more complicated. But the plus C is actually pretty important there. So ultimately here, Q is going to be, well, 10T squared plus 1,000T plus C all over 50 plus C. And now we can find that C because we have the initial condition, which is 0.
So C is just 0, right? Oh, no, C is 1.
No, the 50.
So let's just plug it in, see what happens. We know that Q is 0 is 0. This means 0 is over here. When I plug in 0 for T's over there. So that's just 0 over 50. So your C is 0 in this case. So we don't actually have to worry about it too much. So this means our Q how do I answer the question? A, the amount of salt in pounds in the tank at T minutes. Well, that was it, we just found A. Yeah, for B, what were you saying? You need to find the time when the tank overflows, and then we're going to plug it into this. So when does the tank overflow?
50 plus T equals 2.
Yeah,
Yeah, it's a 200-gallon tank. It overflows once it hits 200 and starts to exceed it. So time to overflow. This is equal to time for volume to equal 200. But we know what the volume is. This is going to be 50. This is going to be 100 plus 2t. So t is equal to 50 minutes. In 50 minutes, it is going to overflow. At t equals 50 minutes, this means 2 at 50 minutes is going to be, well, 10 times 50 squared plus 1,000 times 50 all over 10 times 50.
What if we had a different?
Cancel those.
No, it is. I didn't get
And
this.
take 2 into this, which is 5, into that is 500. I'm not canceling across some, but actually just
Yeah, yeah.
not factoring out yet. So this ends up being 5 times 50 plus 500. And what's that? 750 pounds per gallon. That's a lot.
That seems high.
Yes.
On the top left, you take from 1/50
Yes, that's because the 2's cancel. Like originally it was Q over 100 plus 2t times 2. The 2 I canceled into that. But the volume function, remember, it's always going to be V naught plus R in minus R out times T.
Hey,
So it's the denominator of this before I simplify it. That's going to give us the volume.
but asked about the concentration. I think that what you found was just the amount of salt.
That is the amount of salt. Yes. Did it ask for the concentration? Okay, so it's 750 pounds over 200 gallons is the concentration. Concentration is the amount over volume.
Wait, quick question. Is that over 2 times 50?
Yes.
Shouldn't it be?
Because I put 50 here. So 50 plus 50 is 2
Oh, okay. Sorry.
I left that as 2 plus 50 because I saw that 50 was a common term. I wanted to see that I could cancel it. Because I hate arithmetic. The more I can keep my arithmetic looking like algebra, like there's a common term that I can cancel, I tend to write it like that. No questions? Okay. So, quick review. We're going to review something that we've already looked at. I mentioned it on the first day. We never actually did an example though. So let's just do an example. Newton's cooling.
Number 6.
Yeah. That's why you guys are waiting for that. That's why I showed up today.
It's made the rounds around the area.
Like there's like an equivalent problem out there that's like about a cup of coffee on a table or something. And, you know, you want to make it a little bit more exciting. Newton's cooling law. So just to remind you what this says, let's say T, little t is the temperature of an object at time t. And so the big T is the temperature, and the little t is time. Don't get those confused, they're different. And TA and B B is the ambient temperature. That's just a pretentious way to say surrounding temperature. Surrounding temperature. Right, so the temperature of the environment in which the object is placed in. Then Newton figured out by taking a thermometer and a notebook and doing one of the most boring experiments ever, that so that's called discovering something empirically. You discover it by experimentation. This relationship, that the rate of change of the temperature of the object is going to be proportional to the difference in temperature of the object and the surrounding temperature. Now K is a constant of proportionality.
Wouldn't it
It should be negative. But see my under there, I was going to put that in after I did a little spiel about why we want negative, but whatever. Okay. So K, this is a constant of proportionality. And it basically deals with some property of the object by which what you can measure. So it will usually be some like specific heat or the amount of surface area of the object that is exposed, something like that. There's some physical property of the object that you can measure as a constant, and whatever property of the object you pick and start measuring by that, this guy is going to hold. Now, we usually consider K positive for that reason. And that's why we put a negative sign here. So I was going to start explaining that. It makes sense if we want to make sure that K stays positive, that we manually put a negative sign here, because then that is going to make sense with what the model is supposed to show. You can imagine that if the current temperature of the object is larger than the surrounding temperature, you expect it to cool down, right? Which means the rate of change of temperature should be negative. So if K is positive, that will work.
Can we put
Vice versa, if the surrounding temperature is actually hotter than the temperature of the object, the object will heat up. This part will be negative, however, the negative out here is going to turn into positive, and you get that the rate of change of temperature is positive, it's increasing, right? So you get the increasing and decreasing in the situation where we want it, which is why people usually affix a negative sign here. Technically speaking, though, it's not necessary. It's just for aesthetic reasons. Yeah, what was
can we
someone
put like
saying?
absolute value signs around K, and would the thing still work when we're integrating and
If you put the absolute value sign here, yeah. You can include the negative sign, because that might actually affect things.
Plus, if we just swap T and with that big T, do we need the negative sign at all? Like if we made T and.
Well, if I swap this, then I can get rid of that, yeah.
Yeah.
But this is traditionally how it's written. They put in a minus sign. And again, for aesthetic reasons. You can switch this, it wouldn't make a difference. The only difference is now when you're integrating, you have to remember, technically now you need a U sub, and there's going to be a -1 there that a lot of people forget to put there because they're sloppy. So they just write it so that the T is in front of that, so when you divide by the T minus T ambient, the integral is just going to be the ln of T minus T ambient as opposed to negative ln of T ambient minus T.
Saves you work down the line.
It saves you. So it's really, that form is really just for aesthetic, traditional reasons.
So you don't get a negative specific heat.
Yeah, so we don't want something like a negative specific. Yeah, so that's basically it. Now you'll notice that this is, not only is it linear, but it's also separable. And so we can solve it in general. Yeah. Let's actually solve it specifically for the problem. Okay. So we could solve it in general, but let's actually just solve it while we're doing the problem. So Problem 6 is a Newton's cooling problem. So, here's the situation. You like we're gossiping now. So, a boy gets a girl pregnant, father's not happy with it. Everyone knows he's not happy about it. He's notably very angry about it, as it says in the word problem. Okay? The day after the father finds out about this pregnancy, though, the boy shows up dead. Turns up dead in his room the next day, right? It's air conditioned. The air AC was still on. So the room is maintained at 60 degrees Fahrenheit. And police came on the scene, and here are some things they discovered. One, the murder weapon was in the room that they determined that he was killed with. Two, the body temperature was 80 degrees Fahrenheit when found, and 75 degrees Fahrenheit 2 hours later when they measured it, because they were just in the room investigating this. Okay. Next, the boy's parents obviously blame the girl's father. He has the motive, was actually very angry. The father, however, claims he was at work until 8 p.m. the previous night, and so had nothing to do with him. He has an alibi, and the boy actually probably committed suicide because he was afraid of consequences. It's very dark. Okay, the police turn to you, who you are a mathematician by day, crime solver by night. Okay, so that's your moonlight as an investigator. So you want to help them figure out what's going on. What do you make of the father's alibi? And there's a note here. The body temperature of a human being is 98.6 degrees on average.
He did.
He did. Let's actually figure out what the situation is. So it turns out that the boy's body is the object here, right? The boy's body is T. Well, the T represents the temperature of the boy's body. So we can start to fill in some stuff here. We know that T ambient is 60. This is the temperature of the room. We also know what T is at 2 points specifically.
Yeah. T of 80.
T of what?
Sorry.
T of 0.
T of 0, yeah.
T of something is 80, right? Let's call that 0. Now we are going to just say whatever time he was found. Time investigators got there.
Oh wait, shouldn't T0 be 98.6? And then it cooled down to 80 eventually?
It depends. You could actually do that.
And then TFT would be 80, right?
Yeah.
But T of T can't be 80.
You don't know what the time is. It's T of.
You can say we don't know what time you found and just put T of another variable here. It'll work out though if you just start the clock when you count, right? It's gonna work out. It'll lead to something weird, but it'll have a straightforward interpretation. So, it's actually alive. But he ain't dead, actually. That's Newton's law of cooling told us that. He's still alive. Okay. So start the stopwatch. Okay. Now we're measuring time in hours, right? So they told us what he is 2 hours later.
Oh, we're doing hours, not minutes?
Is it minutes? He's really
No,
getting
it's
specific.
hours.
He's like, let's do it to the second.
Every second counts.
This boy's family deserves justice. God, I'm shaking. It's interesting. I can't. I have a sore throat, guys. Don't worry about it. Come on. Okay. So we know that, and we pretty much don't really know anything else.
FYI.
Well, we know that we're comparing what we get for the change in temperature with when the father said he found it, right?
Yeah.
So that must mean that if it was 2 hours later, then temperature change should correlate with.
Yes. Well, let's actually plug in what we do know so far. T prime should be minus k times t minus 60. Let's actually solve this. That's your cue. You're like, let me solve it. Okay, so.
No, I got the equation, so.
Yeah, that's our equation right now,
Okay.
where 60 is plugged in.
The next one is steps.
Huh?
Next one is steps.
Yeah, let's go.
Okay, so this is going to be D capital T over D lowercase t equals to all of that. Then we divide T minus 60 to dt over that. And we multiply B lowercase t. And we integrate both sides. And we get ln absolute T minus 60 equals to negative K times T plus C minus A. Then you use, E, I don't know how that is.
Yeah, so what do you get?
You get T minus 60 times, T minus 60 equals to C times E to the power of negative KT. Then you have to add 60.
Okay. Okay, so here we have the equation that gives us the temperature at time t. And we have two unknowns here. How do we find them?
Plug in.
Well,
Yeah,
we're given 2 points, so we can actually find it. So if we have t of 0 equals 80, this would mean that you have c e to the 0 plus 60. So in other words, your c is
20.
also, we have t of 2 equals 75. Well, that would be what you get when you plug in t equals 2. So we already know the c, so that's 20e to the minus 2k, because we're plugging in t equals 2 plus 60. How do you solve that?
70 divided by 65, no, 70 minus 65
Yeah,
divided by 20.
Well,
And then
75 minus 60
Yeah, 15 over 20,
over 20,
natural log,
gonna ln both sides.
divide by
And
2.
so your k is going to end up being ln of
15 over 20,
3 over 4, and
raised to negative 2,
Negative 2k, so
negative half,
that one is gonna be
negative
2.
half, right?
yeah, and then raise it.
Right, well, you could do that. Let's see if that's that. So ultimately now, we get that our t is c, which is 20 e to the minus, now become plus 1/2 ln 3 over 4 plus 60. Now what you have to do is to find how long ago was this boy alive. If we assume he was like a normal human being,
Oh, but we could cancel the E too, right? The E to the power of.
yeah, we could.
So it just becomes the square root of 3/4.
20 times the square root of 3/4. There is a t missing here, right? It's t plus 60. Yeah. So now if we set t equals to 98.6 degrees Fahrenheit, we would get what would we get the time equal to?
38.6 divided by 20 square root 3/4.
So, yeah, we said 28.6
Divided by
divided by
20 square root 3/4.
38
Oh, 38.
equals t.
do it?
What, something, I think something's off.
I think it's a minus sign.
Yeah, let's make sure we have the minus signs in the proper situation. This is fine here, right? Then I subtract 60. 15 divided by 20. No, it's actually fine, because ln of 3/4 is actually negative.
But it turns positive. Because of
It was
the.
negative.
Try root
It's
three over
negative
two.
half.
Oh, was there a 2 in there that we forgot about? No. No, not really.
Come again?
Wait, there was a 2. It was negative 2, so negative 2k. So the,
It was e to the negative k, so we plug it in.
but then we still have a factor of 1/2 there that could have gotten canceled out too.
I don't know.
And I've set that equal to 98.6, you subtract 60, you get 38. I'd rather just keep this as,
Why do you think something's wrong?
this thing should be to the power of t, that was wrong. Let's just keep the element in there, because it'll make more intuitive sense, I think, anyway. Because you'll start to notice something. Yeah, because the t isn't inside the element.
Yeah.
So let's just leave this as 1/2 ln of 3/4 times t. And then plug that in here.
What happened to the factor of 2 in the power though?
What's now? There's a 1/2 in front of the ln now.
Yeah, but it was e to the negative 2k, right? And then we k is
It's
equal to
been
negative
1/2
1/2, so then the 2 gets squished.
I have a quick question.
Yes.
So could we multiply t with half and just rework it and just get 3 to the power of 4? 3 over 4 to the power of t divided by 2.
I'm going with this. T. So we have ln of 38.6 over 20. That would give us divided by 1/2 ln of 3 over 4. That should be t, right? Just for fun, you guys can tell me what that is? Like actually plug it into a calculator, because we don't know. This boy's family deserves justice.
This divide 38.6 divided by 3.
Normally no calculators, but I think in this sad situation we can make an exception.
Negative 4.6.
Negative 4.6.
Around.
Okay. What does that mean?
I can see.
It happens at
He died 4.5 hours before they discovered it. Do we know when they discovered it?
The next day, so at least at midnight.
It at least had to be midnight, right? Which means this brings his time of death to around 7:30-ish, assuming they saw him at midnight. But if they found him way after midnight,
They also said day, and I don't think most people consider midnight day.
yeah, so. Assuming they found him at, like, the end of the...
Dude stabbed himself, that is brutal. That is so bad. Twice.
Right? So basically, the negative answer here means he died 4.6 hours before they got there. So they actually got there pretty quick.
Well, like technically you're supposed
We're
to.
4.6 hours too late.
Depends on the electrical system.
Oh,
If you're in Europe, euthanasia.
or you're an anti-natalist.
Yeah, or if you're an anti-natalist.
Now you guys can be like Newton, go home and like measure your cup of coffee. Just sit down on the table for some couple hours. Just to see some calculations, see if it works out. We will stop there.
They like to use this as well for clickbait. They're like Antarctica is, the temperature is rising faster than anywhere.
Yeah. So we'll stop there. So next time, I guess we'll just bring the power through problem 1 and we'll start exact equations. So look up on that.
Oh yes, I have a question.
That's a pretty cool thing. That's also a similar topic to conservative vector fields from 319.
There are the
point. You might notice some people.
Thanks for uploading the 392.
There. Yeah. Oh, let me turn off this thing
question.
here.
There's homework due